Okay, so everybody, this is a guided walkthrough for the Run As machine. It is a Windows machine over at the HackMyVM.eu website, and let's begin. Okay, so for this particular challenge, there's a couple of things we need to keep in mind, and there's a bit of metagaming going on in the box. So we need to keep in mind that there's an administrator user and a Run As user while we're solving this box. So the first thing we're going to do is we're going to figure out where on the network this machine exists at, and go ahead and do that by running nmap. So nmap is a great little tool that we can use for scanning networks and for scanning servers for open ports. But another thing that nmap can do is that it can do a ping sweep. And a ping sweep is basically finding out what devices on a network are online. So we're going to run nmap with a ping sweep by doing this argument here, -sn, on this network range. So if we run this, we're going to see that there are a number of different devices that are online right now, but the only two we need to really worry about are these two that are running with VirtualBox, which is my VM management program. So this IP address over here, ending in 6, this is our attacking machine, which is this localhost, and another machine exists over at address number 19. All right, so we know that the box exists at this IP address right here. So we're going to do another nmap scan against this box to figure out what open ports exist on the server. So it's going to be nmap. We're going to give it -p- to run it against all ports. We're going to do -s capital C capital V for common scripts and versioning information against any services we find. And we're going to run very verbose -v so that we can get information before the scan finishes. So this is pretty important because otherwise we're going to have to wait until the scan completely finishes before we get any output. Okay, so we're also going to run it in T5 mode, which means it's going to run very, very fast. Okay, let's go ahead and run that scan. This doesn't run. Okay, so we're running the nmap scan right now, and we see that there are a bunch of different ports that are open on the system, and there's some ports that are very, very obvious as far as the Windows-ness of this server. So in particular, ports like 445, 135, 139, and a bunch of these ports on the 3000 range here. These are pretty good indications that this server is a Windows server. So in particular, for this particular challenge, we don't need to pay very much attention to the Windows ports, but we do need to pay attention to this port right here, which is port 80. And port 80 is the port associated with HTTP, which is basically unsecured web pages without SSL. So we can go ahead and check out this web page. Okay, so what we want to do is we want to go ahead and take a look at the web page associated with the server. So what is the IP address? The IP address is 192.168. Okay, this one. So we're just going to copy this IP address. Then we're going to go over to our web browser. And in our web browser, we're going to navigate to this page. So the landing page in this case has directory listing enabled, and directory listing by itself is already a security flaw. It means that we can take a look at the complete contents of directories without having any special access. So there's this index.php page here, and there's the styles.css page. We can go ahead and click on index.php. Okay, so what is on this landing page over here? It says there is no going back. There is no going back, and it also has this URL parameter right here. So URL parameter let's talk a little bit about URL parameters before we talk about what's actually going on here. So URL parameters are variables attached to the end of URLs. So they can be identified by the question mark directly after the web page, directory name, followed by a parameter key name, then the equal sign, then a value. Okay, so we see here that this is the start of the parameters, the question mark. Then there's a key, and then there's an equal sign, and then there's a value. If there's more than one URL parameter in the URL, then it's going to be separated by the and symbol over here. So, for example, in here there's a color parameter with the value of blue, and there's another one, sort parameter, with the value of newest. If there are multiple parameters included in the same URL, they are separated by the ampersand symbol. So there are a few different reasons why web pages use URL parameters, and the most common one is for search queries. So anytime you go over to google.com and you search for something, it's going to turn a URL parameter called Q, and Q is equal to whatever you searched for. For example, if we look for apples, that's going to be Q equals apples. So we can actually demonstrate this very easily. So over here, I'm just going to go to google.com, and I'm going to search for apples. So over here, there are actually a lot of different URL parameters here, but you're going to see that there's the search endpoint here, the question mark, and then the Q. The Q is the name of the parameter, and the value of that is going to be apples because that's what we search for. It's basically telling the database what it's supposed to return to us. So that's URL parameters. However, another common and potentially dangerous use of URL parameters is to instruct the web server on which web page to display. So in this case, there's an include parameter, and it's equal to some sort of file. So we can actually take a look at the our own site over here, and can plug this. You can plug this URL parameter over here, the file parameter, and we're just going to specify a web page. So we saw a index.php page over here, and we see that the file is actually what is returned by the web page. So, okay, what are we going to do with this? With this particular information, we're going to do what is called a local file inclusion attack. And let's talk a little bit more about what local file inclusion is. So the use of URL parameters, which reference other files on the web server, could potentially be exploited in an attack called local file inclusion, otherwise known as LFI. So local file inclusion is a web app vulnerability where arbitrary local web server files can be accessed through the web interface. LFI vulnerabilities can lead to sensitive data exposure and can also be used as the first step in a chain of exploits. The inclusion of file names in the URL parameters is a typical method through which a potential LFI vulnerability is identified. So let's go ahead and test our hypothesis back at the web page here. So if we think that there is some sort of local file inclusion vulnerability on the system, and we know that this is a Windows machine, we could try to use local file inclusion to access a common Windows file. So the common Windows file that people usually use to try to figure out if there's local file inclusion on a Windows box is the etc hosts file. So it's going to be, this is the file that lets a Windows host know about special IP addresses that resolve to different hosts. So in this case, we plug in the address or the file path for this particular file. So it's C Windows System32 drivers etc hosts, and because we get output here, that means that this web server is vulnerable to local file inclusion. What that means is if we know where a particular file exists, we can try to read it through the web interface. So this can be a really, really big problem. But they're actually specialized tools we can use to try to figure out which files we can read file inclusion. So let me go ahead and identify one of those. First thing we can actually try to look for which files are available through local file inclusion. But first we need to get a list of different common files inside of Windows. And I've got a list that qualifies. Oh, wait. Oh, I didn't copy the link. Maybe I can find it on the fly right now. Okay, so local file inclusion, Windows, word list. Okay, so let's see if I can find it. Okay, this looks good. All right, so this is a list of different Windows files that we can try to read. If you take a look over here, there are things like log files and MySQL files. So we're going to see if we're going to just run through the list and see if we can read any of these files. So if anybody's wondering what we're looking at this. So I'm just going to copy this list. And then I'm going to go to my Kali Linux and create the list. I'm going to call this Windows lfi.txt. Okay, I'm going to paste in the contents of the list I got from the GitHub site there. Save it. And then I'm going to use FFuF, try to figure out what endpoints we can access through local file inclusion. So the tool that we're going to use is called, okay. There's one thing we need to do before we do this FFuF check, this scan. We need to get the request inside of Burp Suite, and we're going to use the recorded request as a parameter for the FFuF program. So let's go ahead and start up Burp Suite. Burp Suite is a well, one important thing about Burp Suite is that it acts as a proxy between the web browser and the web server. So it can record web traffic that is going back and forth, and you can investigate the traffic because it records it and logs it. So we've started up Burp Suite. What we're going to do is we're going to go to the proxy tab over here. We're going to open up the Burp Suite browser, which is connected to the Burp Suite proxy here. And we're going to go over to that web page. So the web page was at 192.200. 192, 198, 219. Okay, so we want to go to the index.php page, and then we want to insert the parameter, which is the file equals, to the end over here. After that, we're just going to give a test. It doesn't need to be valid. We're just going to send this as a test so that it gets recorded by Burp Suite. Okay, it says file not found. That's great. Okay, so now that the request has been recorded, we're just going to go into Burp Suite. We're going to go to the HTTP history, and we're going to go to that specific request. So that's going to be the GET request with the URL parameter over here. So we do that from the proxy HTTP history tab. You can click on this request with the URL parameter, and then we're just going to save this. We're going to save this as a file. Go down to the request portion of the window, right-click on it, and then select this option here called Copy to File. So we're going to record all of the HTTP parameters inside of this file. We're going to call it request.txt. Save it. After that, we can close out Burp Suite. And then we're going to edit the request.txt file. We're just going to go and edit it using nano. So nano request.txt. And so this is the this is the contents of the request that we're going to be using with another program called FFuF. What we want to do is we want to fuzz. We want to force all of the file endpoints inside of the Windows LFI file that we copied earlier. So inside of the request here, file is going to be equal to fuzz. So this is what is called the fuzzing point. So inside of inside the request file, we have to specify where we want to put our payload. So our fuzzing payload is going to be file equals, because this is where we would put the file that we want to check, like the etc host file. Except it's going to be every word on that particular list that we copied. So we're just going to save out this file now, and then we're going to use FFuF with the request.txt file, and in here we're going to specify a word list. So the word list is going to be Windows LFI.txt. For this particular request, we have to specify to the FFuF fuzzing program that we're going to be using HTTP versus HTTPS with this argument here, request proto, and we can go ahead and see how the server responds to these different endpoints. So each one of these endpoints are associated with a different file, and we're going to find that all of the invalid files are going to have this particular size, and the size is going to be, the response size is going to be 429. What we want to do is we want to omit all of the requests that return 429 for its size. So we're just going to run this again, but we're going to filter on the file size 429. So when we do that, we're only going to return files that we can actually read using local file inclusion. So not very many, but we were able to get some that, let's see. So we can read the php.ini file, and we can read the Windows update log. Okay, so a bunch of different files here. So for example, if we try to read this, let's go ahead and see if we can do this. We're going to go back to the web application. So file equals, we're just going to paste in the file path that we know that we can get something back for. Okay, so what is this file? So this is the PHP's initialization file. So this is a rare Windows machine, a rare Windows server that is running PHP. And this is an important file for PHP. It gives you a bunch of different information. Okay, so this was all to demonstrate how you could potentially figure out what files you can access through local file inclusion. But for this exercise, the method for solving it is actually not super satisfying because we can't actually break into the box. What we need to do is we need to use local file inclusion to read the files, or rather the flag files for the users that exist on the box, and those two users. Hold on. Can I full screen this? Okay, yeah, I can full screen this. So the two users are the administrator user and the run as user. So let me demonstrate. So down here, we're going to try to read a certain file, and what I'm going to do is I'm going to tack these files onto the local file inclusion list for Windows, just because I don't want to read the files. I don't want to read the flags on the stream because it seems a bit rude to read flags on stream, because the organizers for this website maybe don't want people to broadcast that stuff. So I'm just going to edit Windows LFI.txt. We're going to add a couple other So what we're going to do is we're going to add on to the end here the locations of the flags. So the locations for the flags on this system, because we've got the, what are the users called? The run as user and the administrator user. So that would be C users, run as, and then in their desktop directory, they're going to have a file called user.txt, and that's the user flag. Okay, so the other flag is the root flag, which we can find in the administrator directory, in their desktop directory, in the root.txt flag. So we're going to see if we can access these two files over here through local file inclusion. If we can, that means that we've finished this particular challenge. Okay, so let's go ahead and save this out. And let's run FFuF again and see if we can read those flag files. So we were able to read these two flag files with local file inclusion, according to FFuF, which means we've essentially finished the exercise, because the goal of the exercise is to get access to the administrator desktop directory and read the root.txt flag. Okay, so everybody, that was a guided walkthrough for the run as challenge from HackMyVM.eu. Everybody, if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.